If Scuti took our sun's place, its surface would reach deep into the asteroid belt, swallowing not just Earth, but Mars and a billion kilometers of space beyond. Scuti is a red supergiant star around 5,900 light-years away, sitting in the constellation Scutum, invisible to the naked eye. At its most recent measured size, 909 times wider than the Sun, Scuti's radius stretches nearly 632 million kilometers. That's enough to engulf Mercury, Venus, Earth, Mars, and much of the asteroid belt with just its glowing outer layers. It's not just about size. Scuti is a pulsating variable, its brightness shifting every 2 years as its atmosphere expands and contracts. Despite being so faint from Earth, this star shines with over 100,000 suns worth of energy. Even so, Scuti's surface is surprisingly cool, between 3,400 and 3,550 Kelvin, about 40% cooler than our sun's surface. What's even more astonishing? This colossal star has only been burning for 10 to 20 million years. A cosmic blink compared to our 4.6 billion-year-old sun. Massive stars like Scuti live intensely fast lives, rapidly burning through their nuclear fuel due to immense gravity and fierce core pressure. Scuti's volume is so immense that around 750 million suns could fit inside its boundaries if packed at solar density. Take a modern jet and fly along Scuti's equator. It would take nearly 500 years to make a single lap at typical airliner speeds. Scuti's initial mass is estimated at around 25 to perhaps 40 times that of the Sun, which is what drives its fast, furious lifespan. Currently, it's in its late red supergiant phase, already burning heavy elements deep inside instead of just hydrogen or helium. Over the next million years or so, Scuti will shed huge amounts of its outer layers through powerful stellar winds. As it loses mass, the star's outer envelope shrinks, its temperature climbs, and it will briefly transform into a yellow hypergiant or wolf-rayet-like giant. Eventually, fusion in the core will create iron, the element that can't yield energy through fusion, spelling the end for Scuti. When enough iron builds up, the star's energy production halts. Gravity suddenly wins, triggering a dramatic core collapse. This collapse happens in less than a second, crushing the core as the outer layers slam down, then rebound in a cataclysmic core collapse supernova. Scuti's explosion might be seen as a Type 2 or stripped envelope supernova, which can outshine every star in its host galaxy combined for weeks or months. What's left afterwards will be just a shadow of its former self, a neutron star, or, if the collapsing core is massive enough, a stellar mass black hole. Compare that end state, a compact object a few tens of kilometers across, with the behemoth 1.3 billion kilometer wide giant that came before. Scuti is also essential for science because it lies near the physical upper limit for stellar size, the Hayashi limit, helping astronomers refine their models of stellar structure and evolution. Modern measurements from the Gaia mission have recalibrated Scuti's true size and distance, making it a cornerstone for studying hypergiants everywhere. Observing stars like Scuti even informs our understanding of supernovae and black hole formation across the universe by connecting what we see today to explosive deaths millions of years from now. This is the legacy of Scuti, living fast, growing unimaginably large, and then vanishing in a blaze visible across galaxies. One day the universe will witness its final act, a titanic explosion marking the end of a true giant. That's your Cosmic Bite for today. Tap subscribe. I've got a fresh space fact for you every single day.